Here's an equation which we're trying to solve and find a that satisfies this equation. Now notice we have tangent on the right. So tangent is sine divided by cosine, and that immediately tells that cosine of 2a cannot be 0. Okay, we're just going to keep it here, keep in mind, and check every time to make sure that we satisfy this condition. So how can we solve this problem? First of all, let's look what we have. We have a square here minus another square. It makes me think about the formula that tells us a difference of squares. X squared minus y squared is x minus y times x plus y. And let's use this formula to modify this expression. Well, right now expression got much worse than it was before. But let's just go along and see what else can we do. So here I have a difference between cosines, and here I have a sum of cosines. So I know there are formulas like that for the difference of cosines and sum of the cosines. Let's try to use them. First we use a difference of cosines. It's a product of sines. If we apply that formula for the first parenthesis, you're going to get this nice expression, which is much more compact. And for sine of cosines is a product of cosines. We can apply that formula and we get a result like this. The next thing we're going to do, we're going to substitute. We're going to substitute this for the first parenthesis and substitute this for the second parenthesis. And that's what we're going to get. All right. So what's the next step? Well, the next step seems to be to figure out what sine of 5 pi over 4 and what cosine of 5 pi over 4. To do this, we need to remember the formulas like this, that sine of pi plus x is minus sine x, and a similar story for cosine. And we want to use these formulas because 5 pi over 4 is actually pi plus pi over 4, which gives us minus sine pi over 4. And we do know what sine of pi over 4 is. A sine of 45 degrees is 1 over square root of 2. So the answer here is minus 1 over square root of 2. In a similar way, we're going to get that cosine of 5 pi over 4 is also minus 1 over square root of 2. Now we're going to substitute minus 1 over square root of 2 instead of sine and cosine of 5 pi over 4. This is what we're going to get. Now we see there's minus here, it gives me plus. Also I have square root of 2 in denominator and another square root of 2 in denominator. That gives me 2 in the denominator. And I can cancel one of the 2's over here. Let's say we cancel this one. If we do, we get this expression, which looks much more manageable. Now, let's look at the tangent, and remember the tangent is sine over cosine. So let's write it out. To put everything on one side, and notice that both terms have sine of 2a, which we can pull out. Okay, and we get an equation like this. Okay, now let's rewrite it. And now notice that this product of these two terms has to be 0, which means that either sine of 2a equals to 0 or this parenthesis equal to 0. So, okay, the first option is sine of 2a equals to 0. Now, let's verify that we do not violate this condition when we make sine equals to 0, and we don't, because when sine equals to 0, cosine will be either 1 or minus 1. So we're good. But this equation we can easily solve. It means that 2a is pi times n, where n is any integer. And now I divide both parts of this expression by 2 and get a equals pi n over 2, where n is integer. Okay? So that's one possibility. The other possibility, when this parenthesis equal to 0, we get an equation like this. Now, since cosine of 2a is not equal to 0, let's divide both sides of this equation by cosine of 2a. We're gonna get expression like that. And now let's play with this a little bit. We basically separated cosine of 2a from cosine square of 2a. Okay? What we have here is tangent of 2a. And this expression, if we make substitutions, we get equation for tangent. Okay? Now let's open the parentheses. We get a cubic equation for tangent. And now, just to simplify things, let's introduce new variable y as tangent of 2a. In this case, what we need to do is solve this cubic equation. In general, it is not expected from you to know the general formula for cubic equation. So to solve equation like that, you either need to do some tricks or kind of guess the roots. Okay? So let's do the latter. Let's guess some roots, but let's do intelligent guess. We are looking for an integer root. And we also know when we have equations like this, the integer roots are factors of the constant term. So all possible integer roots are either plus or minus 1 or 2 or minus 2. Those are the only 4 possibilities we have to find an integer root. And if you substitute, you find that y equals to minus 1 is a root. Plus 1, plus 2, minus 2 do not work in this case. So now we got a self-cubic equation and we know one of the roots. So, but since we're looking for all solutions of this equation, we really need to find the other roots, because we know a cubic equation could have 3 roots, right? We found one, we need to try to figure out and see if there are other 2, okay? And what they are. All right, so how do we do this? Well, one thing we can actually, if you know one of the roots, we can actually factor this cubic polynomial into 2 factors. One going to be y plus 1, and the other is going to be quadratic polynomial. Now, in this quadratic polynomial, I have 2 constants k and p, which I don't know yet. Okay, I need to find them. And there are a couple ways to find them. If you know an algorithm how to divide one polynomial by another one, you could divide this cubic polynomial by y plus 1, and that gives you this polynomial, quadratic polynomial. The other way to deal with this is to just open the parentheses, okay? And that's what I did, and collect all similar terms. And now what we see, on the left we have cubic polynomial, on the right we have cubic polynomial. And now we would like these polynomials to be equal to each other at all points y, at all y's. And this only can happen if the corresponding coefficients are the same on the left and on the right. Now here I have 1 times y cubed. So I expect to find 1 times y cubed on the other side, and I do. So that's good. Now here I do not see y squared term. It means that there's coefficient of 0 in front of y squared. It means that k plus 1 should be 0. Okay? Now if you compare y terms, I see coefficient 1 here and coefficients k plus p on the other side. So those coefficients should be equal. And the constant term on one side is 2, on the other side is p, so they also should be equal. Okay? So, and it tells us that k and p should be this. K should be -1, P should be 2. Now, our cubic polynomial could be expressed in this way. And we remember that polynomial should be equal to 0, right? And that would be 0 either when y equals to -1, when the first parenthesis, first term is 0, and we already found this, or when this quadratic term is 0, which means that I need to solve this quadratic equation. Now, I'm not going to go into these details. I presume you know the formula for quadratic equation. And if you apply that formula, you find that there is no real solutions. So really what it tells you that the only real solution for this polynomial is y equals to -1. And that means that the only possibility for 2a I need to consider is the possibility when tangent of 2a equals to -1. Okay. Now I want to go back to this condition and to make sure that what I got here does not contradict this condition. Well, it doesn't, because tangent of 2a is sine of 2a divided by cosine of 2a. If cosine of 2a equals to 0, tangent is not defined, or you can say it's infinite. Well, in our case, it should be -1, so we're good. So now we just need to find all the a's that give us this expression. Well, that's not very difficult to do. Let's get our unit circle. Let's get this red line, which represents tangent line. Now find the position on this line, which corresponds to coordinate of -1. This tangent should be -1. That's the point B. And then we'll connect point O and point B with a straight line. And basically any angle that takes us to the straight line is the correct answer. So let's find one of them. Well, first of all, notice that there is triangle OAB. Side OA is the leg of the right triangle, equals to 1. Side AB is also 1. We have isosceles triangle with 90-degree angle at A. So it means that angle at O and angle at B are at 45 degrees. So this angle is 45 degrees, which we have to take clockwise, and that is a negative direction. So this angle would be -45 degrees or -π/4 radians. And well, the rest of the solutions are -π/4 plus or minus any number of half circles we can take, right? So it means that 2a equals -π/4 plus πn, where n is integer. Okay, we divide it by 2, we get a equals -π/8 plus πn/2, where n is integer. So now we just need to combine all the solutions. We know that one possibility is this, guys. The other possibility is this, guys. So together, they give us all the solutions of this trigonometric equation.